Today we'll look at everything you will ever need to know in your biology class about taxonomy and systemics and phylogeny. So we'll look at these examples, but first we'll want to get a few things clear. So taxonomy is based on the lineage system. It's the practice of naming organisms by a binomial. So you got a genus, and then you got a specific epithet, or also called a species. And this is based on the resemblance of features between organisms. Okay, so this is naming, nomenclature. But when we talk about systemics, that is the practice of classifying organisms by evolutionary history, also called phylogeny. So we end up building phylogenic trees. Initially, we built it off based on morphological resemblance, but later molecular data is really driving how we rearrange this hypothesis of different phylogenic trees. So molecular data is really driving phylogeny. And phylo means tree. And tax means arrange. Onomy means knowledge, in case your class talks about etymology. Okay, we'll look at our first cladogram here. So phylogenic trees can be cladograms or phylograms. Phylograms are based on distance of the branches or the time, but those will usually have like little indicator down here. Because there's no indicator, we know this is a cladogram, and cladograms show the pattern of descent. So a lot of things don't matter. For example, it doesn't have to look like this tree. It could also look like that tree, or it can also look something like this tree as well. So what we're concerned about is a topology. The question that they might ask you is square more related to a star or to a triangle? Or is a triangle more related to this or that? So the root of the tree is always indicating the past, and the top of the tree is more recent. If something is more related, they have a more recent common ancestor. So a triangle, every node here, these are nodes, every node represents a common ancestor. So to find out whether triangle is more related to circle or square, you would look at which ancestor is the most recent, and triangle will be more related to circle because they have a more recent ancestor. So you could do the same with animals. What about the square? Square is more related to a triangle than to the star because they share a more recent common ancestor. What about the star, which is near the root? Out of all these shapes, which one is star most related to? Well, since it's at the base, the most recent ancestor could only be this circle here, this node here. So that means all of these shapes are equally related to the star. Okay, that is only for when the thing that you're being asked is at the root. So the topology of the cladograms matter the most. So let's put that into exercise. These are all cladograms, and one of these among the three is representing a different relationship between organisms. So we're going to figure out what that is. And we're going to look at the tops. So the top here, D and E are sister taxa. D and E are sister taxa. D and E sister taxa. D and E are sister taxa. So from the top, everything is the same. Now, D and E, the closest, so D and E branched off from the common ancestor with C. So D, E, and C share a common ancestor by this node here. What about here? D and E share a common ancestor with B. D and E share a common ancestor with B. D and E share a common ancestor with B. So we can tell that A, in this case, is the one that is not representing the same pattern. You see how cladograms were using topology by looking at their branching patterns instead of the roots. Don't look at the roots, look at the tips. So we know cladograms can also be represented in different ways. And here we have another way that it can be represented. And I have a true or false question for you. Blackfish, and by the way, these are like fictional animals I made up from real examples so we don't get copyrighted. This blackfish is the ancestor of triangle, but blackfish is not the ancestor of pinkfish. True or false? So first of all, the answer is false, because this blackfish, the ancestor of triangle, are these nodes. These are the common ancestors. So you can't really say blackfish is the ancestor of triangle, because this node is the ancestor. Okay, now we're going to talk about monophyletic groups and polyphyletic and paraphyletic. And we'll do it with this example here. We have a cladogram, and the questions might ask you, okay, given this cladogram, and then I'm going to pick two animals from here. I got C1 and C2. These are fictional names once again. If C1 and C2 would make what type of group? So C1 and C2. So let me just write down their definitions. So monophyletic is where there is an ancestral taxon and all of its descendants, and no other unrelated taxa. So it's just like your good old regular clade. Now you also have paraphyletic, which is a group that consists of an ancestral taxon, but not all of its descendants. So these are really quick cladograms here. So what that means is, for example, you might have fish at the top. And then we know fish is the ancestor, but sometimes given the question they ask you, is fish and, let's just say all of this is A. Fish and A, what kind of group are they? They are at the top of this cladogram. So they're going to be paraphyletic if it's just going to be like one part of a tree, especially at the top part, but that does not include its descendants. So the definition is when a paraphyletic group is when the grouping consists of an ancestral taxon, at the top, ancestral taxon, but not all of its descendants. So we can say an ancestral taxon, but not all of its descendants. So that would just be like these two or these three, just not all of its descendants. Okay, and then we have polyphyletic group, which is defined as a grouping that includes distantly related taxa, but that does not include the common ancestor. So what that may look like is let's say they say here's a circle here, and here's a circle, and the rest are like other shapes, what have you. And then they say circle 1 and circle 2 form what kind of group? And that would be the polyphyletic group, because they're distantly related but does not include their common ancestors. Okay. Now with this example, the question might ask you what grouping would be C1 and C2. The C1 and C2 would just be two of these ancestors, but does not include any of their descendants. So this would be a paraphyletic group. Okay. The other question they could ask is all of the genus G, so G1, G2, G3, G4, and their common ancestors would form what kind of group? So we see that their common ancestors are included, the common ancestors of G1, and that means the nodes, and everything down from that node, everything down from that node, which are all of its descendants, and no other unrelated taxa are included. So this is monophyletic. So we see how it's just like whichever one they start talking to you about, whichever node, and then everything down from that will be monophyletic. It's not paraphyletic because it's not like anything below this is not included. So it's not paraphyletic. And the last one is, let's say this circle, which I've drawn in the picture here, represents seed-eating birds. So we see that C2 and G2 are seed-eating birds. So what would these two organisms form as a group? Polyphyletic. Okay, now sometimes what they might do with this second question, genus G and the common ancestor, okay, this looks normal, but sometimes what they might do is somewhere like maybe up here or what have you, I'll just change our example here, somewhere up here they might hide the genus G. So when you look at it, it looks like, oh, well, there's all the genus G's, that means it's monophyletic, but sometimes this might be a really, really long tree, and then there are a few more G's hidden in here, and it's in really small text and very blurry, so that when you're rushing, you just think, oh, well, it's just monophyletic. But if another of this genus also exists at the top, this is no longer going to be monophyletic, this would be polyphyletic because there is a grouping here and there's a grouping here, so it looks like our diagram here.